Hi, teacher Jerry here. So basically, for the pure chem students, the second part of energetics is that we need to learn how to calculate. There are many ways to look at whether exo endo. We can do experiment and measure the temperature. We can also calculate based on the bond energy. So let me show you example. What do I mean? But do take note, okay? Every reaction involves bond breaking, bond forming. And we know that bond breaking is endo. So bond making is definitely exo. Right? Means negative, positive. Okay, so let me just show you an example. What do I mean by that? Okay, so this is an example. Right, so you know that color, okay? So you know that here, the reactant, okay, that means the left hand side, right? Any reaction, you need to break the bond first. So here is actually bond breaking, which is endo. Right? Because if the bond is not broken, then technically they are stable. That's why they are bonded, mah. Right? If they're stable, then there shouldn't be any reaction. So we need to break the bond. So later part, you will know that actually all reaction require a certain minimum amount of energy. Actually do what? To break the bond. Right? If you don't break bond, they're stable, there's no reaction. Only after you break the bond, then you rearrange themselves, and then when you move to right hand side, the product, right, you will form new bonds. Okay, bond forming. Right? Then of course, opposite of exo, endo is exo. Okay, so we will use data given like here, all right, the bond energy. So bond energy got no plus or minus because bond energy, when I say bond energy, it can means that you're bond breaking or you're bond forming. Okay, so but on the left hand side, see hydrogen, the H, we take this 100. This is just an example. So then we say 2 times 100. You see, then plus oxygen. This is a double bond. Oxygen double bond because oxygen I mean, in group 16, it will need two more electrons to be stable. So we don't look at the oxygen. We must go for double bond, which is 250. There's only one more of it. Right, then when you go to the bond forming, you see, so you must understand that one H2O will have one OH, two OH bond. So two will have four. So you need four. And then you form bond is so you minus 200. See why now minus? Because bond forming exothermic. So it's negative. This is endothermic. So you add everything together, then you see whether your overall is negative or positive. All right. So you can see that this is 200 here plus 250, then minus your 800. So obviously here is actually your final one with minus 350. Okay, kilojoules. So if the overall is negative, it means that it is exothermic. Right? That's how we calculate. Okay, from data, we can calculate to see whether the reaction is exo or endothermic. Right? Another way to look at it is this. Right? See, the energy is because we must understand is that one mole has 6 times 10 to the power 23. All right. So when one molecule is broken, okay, and then when you form this energy here, the energy, see, that means the bond forming, we know it's minus 800. Right? And then the endo here is your 450. So whenever you form bond, the energy given out here will go and break more bonds. Okay, but of course, the bond breaking is only 450. So, but you got 800 energy produced. So the excess energy will be given out as heat. That's why overall is exothermic. Right? That's how we look at or explain, whether it's endo exo, right, based on the bond breaking, bond forming. Right. So let's get back to the summary there again. Okay, so you can see, yeah. All right, so energy given out in bond forming is less. Then it will be, and then it's endo lah. Right. So similarly, it's just opposite, right? Less and then more. So it's just comparing which one is more, which one is less. Right. And the question normally will guide us explain why the endothermic, exothermic in terms of bond breaking, bond forming. Then this is how we do it. All right. Now the energy content will depends on the energy level and the energy profile diagram. Actually, they're quite similar. The only difference is the activation energy. Right. It shows a curve, the activation energy. Okay. If not, basically it's the same one. So you can see yourself that, for example, it's just like if you're at ground floor, if you need to go up, then definitely you need to take in energy. Right. But if you're at the second or you're at the house, second, third floor, you want to go down, then of course you have to release the excess energy as heat. Then you go down to the ground floor. Right. So that's also how we can look at endo exothermic right? Just be careful whether they're looking at energy level diagram or energy profile. And as shared earlier, all right, activation energy is actually the minimum amount of energy needed to break the bonds in order for reaction to happen, right? Because if bonds are not broken, then they are stable, they will not react, right? So this is the general big picture of the energetics. Hope it gives you a better understanding, and I'll catch you in the next chapter on reaction rates. Right? Thanks.